Hello, everyone. Welcome to CPE 517-WS Digital and Computer System Architecture course. This is the lecture 2. We have 6 parts for lecture 2. So now part 1, integrated circuits. I'm Professor Hang Liu. First, some logistics. So for this class, some of the slides will be adopted from the textbook slides and other researchers, such as David Patterson, Sen, Lapsty, and etc. All the credits goes to the original authors, and all the errors are mine. Reordering and modification might be applied due to the requirement of this specific lecture. Integrated circuits, okay. In the bottom, you see here, this is the, assuming we have the wafer here, right? So this circle is the wafer. Every square is like a die. Yeah, right. This is a wafer. Okay, it's supposed to be wafer. Okay. And then how many dies can we manufacture from the wafer is the question we want to answer in integrated circuit cost, right? The cost of the integrated circuit is the cost of the die plus the cost of testing the die plus the cost of packaging and the final test divided by final test yield. So basically, the cost of a die is the cost of a wafer divided by dies per wafer multiplied die yield. Okay. Assuming we have the die here, then the size, assuming we have per die here, then the size of the wafer is pi radius square divided by the die area, subtract pi multiply the wafer diameter divided by square to multiply die area. Let's see why. Okay, why is that? So we have, let's see. Okay, this is the wafer radius, right? So the diameter divided by 2. Okay. And then you have to subtract these areas. So it's basically this is the area of wafer, right? Divided by the area of the die, and subtract those surroundings that actually cannot surface one entire die. That is the diameter or the circumference. Okay, let me change the color. The circumference divided by the diagonal of each die. Okay. So assume it's like this. See here, die area. This equals the length of this. You multiply this by square root 2, that is the diameter. So you can see this definitely overestimate the area, right? So it's overestimate the area, but clearly this is the cap or guaranteed number of dies we can produce per wafer. Okay. Okay. So with this equation, please use 10 minutes to solve this problem. Find the number of dies per 300 millimeter wafer for a die that is 1.5 centimeter on a side, and for a die that is 1.0 centimeter on a side. Okay, so try to solve both of them. Okay, this is the solution. Okay, now let's go to the second part of this lecture. The Amdahl's law, right? So the second lecture part is Amdahl's law. We have 15 minutes for lecture and 15 minutes for exercise. I'm still Professor Han Liu. This is Digital Computer System Architecture course. Okay. Measuring the performance. Typical performance metrics are latency and throughput. We discussed about that. But typically we also take a look at the speed of x relative to y equals the execution time of y divided by execution time x, or we say the performance of x and y are reversely proportional to the time consumption of x and y. Execution time or clock time includes all system overheads. CPU time only computation time. Benchmarks are kernels, like a matrix multiplication kernel, toy programs, synthetic benchmarks like Dresden, benchmarks weights, which we're going to spend a lot of time on today. Defining performance. So what is important to whom? Computer system users